Hello, how are you? Hello, hello. Okay, there we go. Well, good morning. Uh, Thank you very much. Or I should say good morning, good afternoon, good evening, wherever you're. Joining from. I'm Mark Nelson. I'm the technical marketing engineer from Hazelcast. And today we're going to be discussing stream processing with Hazelcast. Today we have, I think, a very interesting and exciting use case that we're going to be demoing that's just hot off the presses. It's an IoT architecture that we've been developing recently. And so let's get into it. Today we're going to go over what we're calling, well, we're not calling it this, the genesis of it is this News2 algorithm that was developed out of the United Kingdom. Then we'll go over a little bit of the architecture, and then we'll have a little bit of a code review on the streaming pipeline, and we'll do a little demo. And then also I'll show how you can integrate the stream processing into the Python rules engine that we developed. This is a precursor to basically doing machine learning that you can plug into the streaming insights, streaming pipeline, and provide insights into so you can get some real-time information, decision making out of the tool. So without let's go on to the News 2. So News 2 was developed out of the Royal College of Physicians of the United Kingdom. The essential purpose of it was to come up with an algorithm or a set of parameters that are typically recorded manually across the day for a patient. They can be done more frequently, and then these scores are summed up into a value. That value across these what is now 8 parameters would determine if this person needs further medical attention. And that was what the stream processing engine was attempting to capture, was the fact that if you had the ability to collect this information in real time, you could help, instead of capturing this information manually, you could actually set up devices, which pretty much already exist, but you could then monitor a patient continuously, and then applying this algorithm to it, you would be able to get in front of when this person's when the patient's vital signs needed further triaging. So basically, what we did is we have 8 different data streams that we've created: respiration rate, oxygen saturation. There's 2 variations of that. There's observations of whether or not the person's actually on air or on oxygen. That would be if the person's actually in the hospital. There's some criteria that would go into that situation, whether or not the algorithm, how the algorithm handles that. Systolic blood pressure, I'm sorry, heart rate, consciousness, whether the person's alert, or if they're in some other state. So that's what the CVPU stands for, and then their temperature, of course. And then basically, based on that information, they would fall into these categories of, you would score that out and then be able to provide a low, medium, or high score for that. So that is that chart 2 is what essentially happens with the Python rules engine that we'll show you later. So with the IoT processing architecture, essentially, again, this was what we would be looking at sort of in a theoretical level. So you'd have these 8 devices that would be connected to the person that would be then sending data into the message bus. We were using Apache Kafka for that. And then that would get processed into Hazelcast. That would, our stream processing engine, which then could send that information to the Python to be able to score that information out, and then send that to a Graphite database and Grafana for visualization. So basically, so the device data, this is another representation of the pipelines. The visualization here is that the device data comes in, we write that to our in-memory key value store. And then those metrics get written out to the Graphite database. Then we also write that information to the metrics from the map journal. And then we can calculate the risk score using the Python module, and then return that risk score to, again, some sort of alerting system. In this case, we're going to use the Grafana to provide that. And then lastly, this is a representation. Here we're using CSV files to represent the device data. So we had to create a bunch of information there. Essentially, it was basically an ID for the patient, and then various values for that represent the metrics that we were going to get from each of the devices that were going to be sent over, and then a timestamp. So we were actually going to send information every second, according over a 24-hour period. So we were trying to demonstrate that we can ingest millions of records, and then also from various data streams. So that's a lot of information that we're ingesting into the system. And then again, Kafka is taking that in and then publishing it over into Hazelcast. So, okay, so we'll move over to the pipeline demo. So for our pipeline code, we have a couple of prerequisites. The Java 1.8, obviously, for the which we need to have for the streams and Lambda processing. We're using Apache Kafka with Zookeeper. We also have the Hazelcast, of course. We're using 5.1.1 Hazelcast Management Center for the visualization. We're using Docker for the Graphite element. And of course, Grafana and Graphite for the databases and visualization piece. So the code consists of 8 Kafka producer modules. So for each simulated device data stream. That all feeds into the main data loader, which is the main program. That consumes the data from the producers and feeds into the Python rule engine. There's about 4 helper classes. Obviously, there's a patient class that represents the ID and device values for each of the data streams. There's a utilities class that handles the sync. So, we've got the producer modules that basically act as sources, and then the utilities class is handling the sync, which is where you're then sending the data for the data process for the data visualization piece. My graphic metric and the my graphic 2 are just representations for the graphite output. We needed to have 2 of those for one to handle the basically all the data is either in integer format, but the temperature, of course, is a float. So we needed to have a separate class for that. Then there's the scripts to compile and run the programs and the data for the simulation. Pretty simple and straightforward there. Okay, so let's get out of the presentation piece and switch over to the demo. So to do the demo, we need to start up Kafka. So let me get that. Running, and then that's the Zookeeper. And this is Kafka. And then we'll start up Hazelcast Management Center. as well. And then I'll also start up Grafana. Okay, so let's just make sure everything is up and running. Looks like Kafka didn't catch. Okay. Okay, everything's up and running. Okay, so then we can switch over. I want to show Docker. So here's our Docker Graphite container. Really, we did this for just simplicity. Let me get that running. That starts up pretty much right away. We got that running now. And then now we can go over to just check some things here real quick. Okay. All right. So real quick, we'll show the code here. So we have our scripts. Basically, this the start and stop the processes. We've got we got the producers, and then the map data loader. I'll go into that in a little more detail. I have some logs here, which will show you the processes. Once we kick everything off, everything will be running. We've got our Java code here. So we got all our producer modules. Again, the map data loader will go in more detail with, and then we've got in here, we've got, okay. Then we got our data, and we got the Python code here. So for the data, at this point, we don't have the data merge. We just basically have healthy and sick data. But here, this is a simulation of basically the devices. So yeah, basically that's just what we're showing through. But again, we've got tons of it that we're sending through the system once we get it loaded. And then here is the producer. So this is for the air oxygen, whether or not the person is on air or they're on oxygen. This is set up to pull in the data from the healthy metrics. It sends over first it loads in the that file. So the healthy air oxygen. Yeah, breathing device. So it feeds in, loads that in, and then loads it into the Kafka producer. So we'll see that in action, and then this sets up the Kafka properties there. So essentially, that does the same thing for each of these devices. So then in the map data loader, this is where you set up your topics. So again, you have your air, oxygen, consciousness, heart rate. Here's where you set up your connection to Hazelcast. And then you submit your job. The job submission here sets up the pipelines. So this is where the stream processing takes place. Sends the data through Hazelcast into the sinks, where then it's being calculated. So you can see there's a lot of processing that happens there. Then we format that here to send into the results map, which then can get processed by the Python code. So that's set up over here with the find risk, which maps back over here into the Python. So these are just, again, the helper classes that we discussed. These set up the, again, most of this is, these are integer values, but then we did have one that was a float. And then we had these utility classes that helped with a sync to the Graphite database. And then we have the patient information, which essentially is what, captures the information about all the data streams. So these are all the values that then get used to calculate for what the patient is used, their current state. So let's see this in action. We'll start with this. The script basically compiles the map data loader, and then all these scripts essentially compile the Kafka producers accordingly, and then they send out this output here. So this main script will run the program. So let's launch that. And then we'll see here the logs populating. Open these up. Yeah. Now it's going to start running. Okay, so then we can this down. Okay, so now we're in Hazelcast. We can see we've now have the cluster up and running. We have our one member now. We have our maps. They're populating. And then we have our jobs. They're starting to run. Let's go back to, we can see our log file is publishing the Kafka topics for each of these values. Okay. Then let's get back over to this risk detector. This is the Python scoring element. So that takes a couple beats to start processing. So in the meantime, we can go into SQL console. In the SQL browser, we can look at some data here. Oops, fine. Okay, there you go. So our maps are populating. Cancel that. Jobs. Oh, this detector is running. Now we can run over here, back over here. Refresh that. Now we have results. And really should have showed you the results data. That's a little more informative. There we go. Okay. So this is where it all comes together. So before, as you saw, you had the patient, basically the patient ID and just one of these values. So that was what was represented by one of the streams. Now we've combined all that data into one record for this person. And now we can take that one record and now score it. And then with that score, as those records come in, we can keep scoring for that person. And as we score those, we can now show over the course of the day, are they staying the same? Are they getting worse? Are they getting better? And if their condition starts to worsen, then they can take immediate action. And that's essentially what we're trying to show here, is the fact that if you're monitoring this person on a regular basis, that with these devices and streaming that data into the system with Hazelcast, that you can be basically providing a better outcomes, patient outcomes, than if you had to do all this manually. So cancel this. Let's go to the console. Results. Entries. And here we go. And again, this is just the output for the records that we have. So low is essentially what the all these records, again, we showed you all the healthy records. Essentially, so that's what this graded out as. All of them are going to be low, obviously, because they're all healthy. So and so with that, let's switch back over to the code. And yeah, and then you can see all this. This is the processing that's happening in real time. So while that's running, let's show this is our Python code. And this is also pretty simple and straightforward. It's just basically taking in all the data streams from this input list. Each record It then passes in each of those values and scores that out. So it calls these functions and scores them out per the criteria that we've coded in. So if, for instance, on the heart rate, the logic is if, based on the value where they fell in on that chart before, they would either get a 3 or a 0 or a 1 or a 2, and then we would send that score back. And then we would then add up all the scores and then provide, again, this, where they fell out in that range, they would come back with a low, medium, or high value that then that person would end up getting. So that's what that ends up equating to. So, okay, do we have any questions? That's about all I was planning on going over. We plan on refining this demo and code base over time, and hopefully we'll get some better visualizations of it. So it's a little more impactful. But we did want to just demonstrate and show our stream processing capabilities with Hazelcast. So. Okay, well, if there's no questions, thank you very much. I appreciate your time today. And we're looking forward to talking to you again in the future. Thank you.